The last video taught us how to create processes and their benefits on concurrent work. From what we saw though, they seem pretty isolated. What if you wanted to have two processes communicate with each other? That is where message passing comes into play. One process can send a message to another, and that process can listen to it. This is all done asynchronously, so you don't care if you get a response immediately. You send a message to a specific process ID, and that process checks its mailbox. So let's go ahead and open up our terminal, and we'll create a new project. I'll make this a little bigger. And first I'm going to CD to my desktop. You can create your project wherever you want. And I'm going to do mix new, and we're going to call this ShoppingCart. And let's CD into that directory, ShoppingCart, and then go ahead and do code dot to open up Visual Studio for us. All right, we can close the welcome message, expand lib, and let's open up shoppingcart.ex and delete this hello world function. So let's create a process similar to the last video, but this time it will be for our shopping cart. We will want to make a start cart function that will spawn our shopping cart process. And the function we want to call from spawn is going to be our listener that waits for messages to arrive. Okay, so let's go ahead and create our public function called start cart. And that'll just have a do block. And then we're just doing our spawn and then our anonymous function. And it's going to call a private function that we haven't written yet. And we're going to call that listen. Okay. And then we can just go ahead and end this. And that's all we need for our start cart function. And now for our listen function, it can be private because we're only calling it from within this module. So we're going to call it listen. This function needs to be recursive. So basically, when we're waiting for a message, it's just sitting there and waiting. And when a message comes in, it then processes the message, and then we need to call this function again. So after we process a message coming in, it sits there and waits for the next message as well. So it's a recursive style function, okay? And what we need to do is to receive a message inside of this function. We need to create a receive block here. And so the way this works is it pattern matches to your message type, and then you can have a tuple with a value. So in our case, like say we do add item, the value could be like the item name. Okay. And then inside of this is where we could do whatever we need to do to add the item to the cart, right? For now, we're just going to do an IO puts, and we'll say item added to cart, colon, and then we'll use the variable that we just got from our message called item name. And now where the recursiveness comes from, after add item is received, this process would shut down unless we tell it to call listen again. So if we didn't recursively call our function, this process would end after it completes what it does. But now we're having it listen, so it is recursively looping through, which I think is pretty cool. And now this is a simple example, but we can test this out in our Elixir shell now. So if we pull up our terminal and we have to start our shell, so IEX space dash capital S space mix. And now all we can do, we just have to start our process, and we're going to remember to save this to a PID, okay? To a variable, I mean, which is our PID, process ID. And so we're going to do shoppingcart.startCart. And there we go. We have our process ID, and if we double check that, we do have it. And we can even do process.alive and pass that in, and it's true. So our process is running and it's alive. So now we can pass this process a message. And how do we send a message? We just use send and then open up those parentheses, and we need the process ID that we want to send the message to, which is our variable PID, and then what we're sending. And in our case, we need to send a tuple. And the first item is the message type, which is add underscore item. And the second item is the value, or in our case, the item's name. So if I say in quotations, Apple, then it will pass in Apple. And then I can close off this parentheses. And now when I hit enter, it's going to send the message. And there we go. We see our IO puts string, so item added to cart. That's pretty cool. So we sent a message to our shopping cart, and it grabbed it out of the mailbox and then pattern matched the message type to run our code. Let's talk about how messages are stored in processes' mailboxes. Every process has its own mailbox. And if the process isn't set up to receive them, they will just sit in the mailbox until they're checked. So a quick way to demonstrate this is using our Elixir shell's current process. We can send ourselves a message. So we can basically, instead of sending in our PID variable, we can say send open parentheses. We can just say self. And here, let me just show you. If we type self here, that is the process ID of our Elixir shell, okay? So if I say send message to self, and we can pass in anything. It could just be a message type or a tuple, but we'll do a tuple, and we'll say new message is the type, and we'll say hello IEX. And then close off that tuple and close off this function. And so now when I hit enter, we see that we sent a message, but obviously nothing returned because our IEX shell isn't listening for them. So how do we know if we have messages? Well, we can check our process.info. So we can do process.info and send in our process ID, which is self. And I could just hit enter here, and you can see everything, all the info with this process. And somewhere in here, we would find messages. Here we go. So, nope, that's our history. So somewhere in here, well, anyways, to make it easier, we can also just pass in the key messages and it'll return. So it'll keep a list of messages with the message type and then the message. We can also use a function called flush from within the process we want to check. This will return all the messages sitting in our mailbox and then clear them out. So right now we have a message sitting in our mailbox. Now, if I type flush, we get that message returned to us with an OK atom. But now if I check our mailbox with process.info, and now our mailbox is empty. So flush will return all the messages and empty the mailbox. If you just want to check the messages, you can use process.info. Now, how can we handle different kinds of messages? So it's really just like using a case statement. We pattern match for our message type and handle it accordingly. So we can also track state and manage items in our cart instead of creating them manually, like we've done in the past. So if we wanted to add state to our shopping cart process, our listen function could take our cart. Okay, so our cart is now, it could be a list, right? Which, like in past videos, we always created our list and then passed it into functions. Well, this we can kind of automatically set up our cart without having to do anything from the client side. So when we spawn our cart, we can pass in the initial cart, which would just be an empty list. So now we can have our recursive function here and always pass cart back through. And so it maintains our list. So if we add this item, right now we're just saying IO puts blah, blah, blah. It's just a message, right? But we could actually prepend our list with a new item. So we could say our new cart or updated cart. And then inside of square brackets, we can say our item name and then cons operator, so prepend it to our cart. So now it just added it to the front of our cart.
Hi, I'm Jacob. I help companies build scalable, fault-tolerant systems in Elixir. With over a decade of experience, I specialize in solving complex technical challenges, whether that's architecting new systems, implementing real-time processing, or scaling existing applications. I work with teams worldwide to deliver high-performance solutions that deliver results. If you need help with your next Elixir project, visit elixirmentor.com to schedule a call.
And then all we have to do, instead of passing in the cart that just came through, we want to pass the updated cart. So new cart gets returned. Okay. So that's pretty sweet. Now we're maintaining state, right? But how can we actually check that we're maintaining state? Well, we can create, so like I said, you can use a tuple for pattern matching if you want to send more information, because it kind of just takes up one variable spot or one parameter spot. But if you don't need any extra information, you can go straight to just pattern matching with a message type. So we could say show. So this could be our function that shows our cart, right? And now down here, we're just going to do an IO puts, and we can just say our cart colon, and then pass in our cart variable, but we have to inspect it. So it flattens out our list because cart is a list. So it wouldn't just print like a string. So there we go. And now it would just show us what's in our cart. And then like always, since it's recursive, we don't want this process to end yet. We're going to call listen again, call ourselves, and then just pass the cart back in, because we're not actually updating it. We're just maintaining the state here. So if I save this and recompile, now when we should shut down the process we created because it doesn't have the state yet. And I don't want to just make another process. So let's just make sure our first process is still running. So process alive, and then pass in our PID variable, and it is still running. So we can actually do process.exit, pass in our PID, and then a message for why we're exiting. This can be anything. We'll just be, we'll just say exit. So there we go. And now if I check if it's alive, it's false. So we don't just keep a process running out there. Now we're going to start our cart again. So let's do PID equals ShoppingCart.startCart. Okay. And now when we add an item, so if we say, oh no, we just want to send a message. So if we say send to this process, our shopping cart process, and then we need a tuple, right? And we need our message type, which is add underscore item, and then the item. And we'll do an apple again, and then close off those parentheses. And now when I hit send, we get our IO puts message. We get an item added to our cart. Awesome. So now if I send a message, so send to the same process ID, and we want to just see show. So I want to see our cart. We should see cart colon and then the items in our cart. And look at that. We can see our cart. So we're actually holding state without passing in a ton of variables, which is really cool. So now you can imagine thousands of customers, they all have their carts in separate processes, and that process has its own resources. So that's really, really cool. And if you remember in the process video, we handled 10,000 processes all concurrently, and it was like blazing fast. So that's really cool. We're actually able to put a process to work now. Now imagine if we want to remove an item. Well, we can do that. So let's add another tuple, and we'll say remove item and item name. And then Now, inside this case, we want to think about this. We can't just call list.delete and delete this item. Like, what if the item doesn't exist? It might not be in our cart because we're just randomly sending strings, right? So we want to handle that error a little bit. So we can actually just do an if statement or an if block here. We can do if item name in cart. So it will check our list. If the item is any of the things in the cart, then it will delete it. So we can say new cart equals list.delete, and then we pass in our cart and then the item we want to delete, which is our item name. And then we can just go ahead and say IO puts. So we have feedback from our client side. We can say item removed, and then we can say what item that was, which is item name. All right. And then we need to recursively call our listen function again and pass in the new cart because the cart's been updated. So what happens if this item doesn't exist? Well, let's just throw in a little else statement here, and we can just say IO puts and just say item not in cart. So the user gets feedback, but we don't have to do anything. And then we can just call listen and pass in the cart, the original cart with 0 updates. All right. So let's go ahead and save this. And if we go back to our terminal, we can recompile. Cool. And now let's add another item. Let's add, I don't know, a pair. Let's also add milk. Let's also add, what else should we add? Steak. All right. Now, if we go and say show, we get our cart back. So we have steak, milk, a pear, and apple. And that's really cool. And now let's try removing an item. So remove. And let's remove an item that we have. Let's remove the steak. All right, so remove, did we not have an IO puts for that? Oh, item removed. Remove item, is everything spelt right? Item name in cart. We didn't get feedback. So like I'm kind of questioning, let's see, process.alive. Okay, it is alive. So send remove item. So we didn't do anything wrong. Our code is all good. For whatever reason, I had to reboot the IX shell. So let's go ahead and do IX-S space mix. And now we can set a new PID variable, and let's just go ahead and restart our cart. So there we go. Now our cart is started, and now let's just add some items to it. So a tuple, add underscore item, and then we'll add an apple again. Tuple, close those parentheses, and hit send, and there we go. We added an apple to our cart. And let's just add a couple more items again. So pear, all right, and then we can say orange, and I still want our steak. So now let's go ahead and check that our cart has items in it with a show. And there we go. We get our cart back like we did before. And now let's try to remove an item. So let's go ahead and say send our PID in, and inside of a tuple, it's remove underscore item. And let's go ahead and remove our pair and close that off. And now when I hit enter, there we go. Item removed. Awesome. Let's check our cart again with show. pair is no longer there. And now let's try to delete the pair again, and we should get our message that says, items not in cart. There we go. Item not in cart. So that's pretty sweet. I'm sure you are seeing the power with using these message passing techniques and processes leading to a more responsive and robust shopping cart system. You can handle tons of customers, control their shopping experience in their own process, helping manage sales and inventory validations. So I'm pretty excited to continue learning about processes in the next video as we discuss linking and monitoring processes. You'll see how to properly handle processes crashing, and we'll even show what not to do. So with that being said, I'll see you in the next video.